Okay, so question number 1 is a type 1 question. I have yet to randomize any of these, so it's always going to go numerically. Okay, you have 250 grams of water. They told me 2 things in that sentence. What are they? Right, water and mass, so that I know what little m is. Okay, little m is going to be 250 grams, and big M is H2O. All right, that'll help me get the actual molar mass for that. So there's hydrogen, there are 2 of them, so I multiply that by 2, and then I add that to the single oxygen, and I get a molar mass of 18.02 grams per mole. All right, how many moles do you have? So I'm looking for N. Don't have to do any algebra on this. The mole equation is already set up to solve for moles. Okay, so we just plug in our numbers. 250 grams divided by 18.02 grams per mole. Okay, the grams are going to cancel and we'll be left with moles. So 250 divided by 18.02. All right, so we're looking at 13.87 moles. Okay, questions on that one? Okay, how many people have done the second one? Oh, let's look at the second one too now. All right, in this one, I have 27.25 moles. What did they give me there? N. Yeah, they gave me N. Okay, of calcium bromide. That will help me get big M. But what do I need to do with this because they gave it to me in words? I got to drop and swap, okay? Really remember to do that. That is exactly the way I would do it on a unit exam. I would not give you the formula, okay? I would give you the name and expect that you can do the formula yourself, okay? So 2 plus, 1 minus, so CaBr2, whoops. Okay, and then so that's going to be 40.08 plus 79.9 times 2. Okay, so 199.88 grams per mole. Okay, I've got N and I've got big M. And they want to know what is the mass. All right, so mole equation is N equals little m over big M. I've got to isolate little m. What do I do with big M? Multiply it over to the other side. Right? Okay, now I've got my formula. Okay, now I can plug in my numbers. So that'll be 199.88 grams per mole. Okay, times 27.25 moles. Moles are going to cancel. Okay, we'll be left with grams, which is what we're looking for. Okay, so we got almost 5.5 kilograms of this stuff. Okay, 5,446.73 grams. Okay, that's a lot. Okay, that's like over 10 pounds. That's stuff. All right, I'll put the other one back on the board. Okay, you got a type 3 and a type 4. What do you have to use in type 3 and type 4? Right, 6.02 times 10 to the 23. That's Avogadro's number. What does it tell you? It tells something about moles. The number of particles, right? Either molecules or atoms in a mole. Okay, so you will either multiply by it or divide by it. Okay, you have to consider whether you're trying to get a big number or a little number. Okay, there you go. Give you a few more minutes. Okay, see, I did randomize this. I said I didn't, and then I did. This is what type of question? This is type 4. Okay, I'm asking you for the mass, and I give you the number of molecules. Okay, so I gave you a really big number. What do you want to do with Avogadro's number? You want to divide by Avogadro's number here. Okay? When we take this number, okay, the number of molecules, and divide it by Avogadro's number, we get the number of moles. Here's why. Okay? I have the number of molecules on the top. Okay? And I'm dividing by molecules per mole. That's what Avogadro's number is. It's the number of molecules in 1 mole. So when I divide the number of molecules, this number, by Avogadro's number, the molecules cancel and I'm left with moles. Okay? So first thing I want to do, okay, write down my givens, same as always. Okay, so we'll have number of molecules here. Okay, and that's going to be 4.5 times 10 to the 25. Is that a lot? I mean, even 6.02 times 10 to the 23 is a lot, but is this more than a mole? A lot more? Yeah, like maybe close to 100 times, okay, something like that. It's 2 factors of 10 bigger. It's 25 versus 23, okay? All right, and it is lithium sulfide. So big M, okay, lithium with sulfur, that's a -2, that's a +1, Li2S. Okay, so that's going to be 6.94, that's lithium, times 2, plus 32.07, that's the sulfur. Okay, so we got 45.95. Whoop, 45.95. Okay, grams per mole. Okay, everybody with me there? All right. So now, if I'm going to get the mass, which is what the question wants, I need N. I need the number of moles. Dividing the number of molecules by Avogadro's number is how I get that. All right, so I'm going to take this and I'm going to go N will equal 4.5 times 10 to the 25 divided by 6.02 times 10 to the 23. That's going to get me a nice small number, well, smaller than those. Okay, and then I can use that for N. All right, so 4.5, whoops, not alpha. 4.5, go here. Come on. Oh, more coffee is necessary. 4.5. 25. There we go. Divided by 6.02. 23. Okay, so my estimate wasn't far off. It's 74 moles. I was thinking it was close to 100. That's reasonably close to 100. Okay, so I've got a lot of moles here. 74.75 moles. Okay, I'm rounding off on the board. Do I round off on my calculator? No, keep all the decimals till the end. Remember, we're dealing with big numbers here, so we have to keep all of our decimals. All right, so now that I've got N, now I can find M. Right, so little m over big M. Type 4's got the most work, right? You got to do that division operation, you got to calculate molar mass, you got to do algebra, okay, and plug in your numbers. So, as we said before, we're going to multiply both sides by big M to get our new formula, and then we're going to plug in our numbers. 45.95 plus, or not plus, sorry, times 74.75. Okay, I have a lot of that stuff. Okay, almost 3.5 kilograms of it. Okay, so 3,434. 80 grams. Okay. Are these very patterned? Okay, so you have to learn 4 patterns basically. Okay, as long as you can identify which pattern you have to use, you're pretty much set. Okay, That's why we're spending so much time practicing it. I know you're getting bored with it, but that's why we're spending so much time practicing it. It's just the patterns. Once you learn the patterns, you're set. Okay, I'll put number 4 up and give you a couple more minutes to finish that, and then we'll go through it. All right, so on this one, we have a type 3 question. We're looking for the number of molecules, which is a huge number. All right, so we're probably going to be doing what with Avogadro's number here? Multiplying by. All right, so we are looking for the number of molecules. Okay, that is our question mark. Okay, we know that it is potassium carbonate, so that'll help us get our molar mass. Potassium's a +1, carbonate, okay, is a -2, drop and swap. Okay, so we're looking at 2 potassiums, 1 carbon, and 3 oxygens here. Okay, so potassium 39.10, okay, times 2, because there are 2 of them, okay, plus 1 carbon, 12.01, okay, plus 3 oxygens, 16 times 3. Okay, so 39.1 times 2 plus 12.01 plus 48. Sorry, that's 16 times 2. That's cheated in my head. Okay, 138.21 grams per mole. All right, and we have 500 grams of that stuff. So we have little m. Okay, we are looking for the number of molecules. If I'm going to get number of molecules, what do I need first? I need n. Yeah, I need the number of moles. Okay, because Avogadro's number is the number of molecules in 1 mole. If I'm going to multiply those, I got to get n first. Okay, so n is going to be little m over big M. I have both of those numbers, so it's just a matter of plugging it in. 500 grams divided by 138.21 grams per mole. Okay, grams are going to cancel, be left with moles. 500, okay, divided by 138.21. Okay, so we got 3.62 moles, but I'm keeping all the numbers in my calculator. 3.62 moles. Now that I have that, now I can get the number of molecules by multiplying by Avogadro's number. 3.62 with all the decimals times 6.02 times 10 to the 23. Okay, so take my calculator, grab that number, okay, or put it in the memory or whatever you do for yours, okay, and then 6.02 d23. Okay, so we have 2.18 times 10 to the 24 molecules. Okay, do you need to write molecules after it? You do, that's the units. Okay, units are important. Without units, numbers are just numbers, and then it's math. Okay, we do science here. Science has units. Okay. All right, questions on that one? All right, I'll give you a 5-minute break here, then I'm gonna put some more on the board for you to do. Okay. Okay, on the board, there are some of those story-based whole equation questions. Okay, I know they're not exciting stories, and they're not nearly as funny as that meme that nobody gets. Okay, but you guys get that, right? Yeah. Okay, because I had like 2 people separately ask me, why aren't they making them anymore? Not more, longer. Should you make this yardstick longer? No, that's why it's funny. It's not making them any more, it's making them any longer. It's just not as much fun when you have to explain it, but yeah. It's a dad joke, so I understand. Okay, let's give these ones a try here, guys. Okay, just read them carefully. I mean, in the end, it's really like the last sentence that's got the important information in it for most of them. So you're looking for things like, does it give me moles? Does it give me N? Okay, does it give me mass? Does it give me little m? Does it give me number of molecules? Okay, just read through the question, see if you can pull those from it. I mean, they're usually going to be numbers, okay? So you're looking for numbers in the sentence. Look for the units. If it's in grams, you know it's little m, okay? Things like that. Okay, guys. So let's have a look here at number 5. So it says the student did this experiment where they put a strip of copper in an aqueous solution of silver nitrate. Okay, the initial mass of the copper strip was 2.97 grams. Okay, how many moles is this? Okay, can I find out how many moles of copper are in 2.7 grams? Or 97 grams? Yeah, because this is my mass. Okay, my molar mass is going to be for copper. Okay, because it's just copper, so 63.55. Okay, grams per mole. Okay, and then I'm just going to find the number of moles. Okay, so N equals little m over big M. Okay, so it's going to be much less than a mole. 2.97 divided by 63.55. Okay, so I've got 0.05 moles, okay, because I'm rounding this up, right? I'm only keeping 2 decimal places, so 0.05 moles. All right, next thing I want to know is how many atoms. It's asking atoms because copper comes as single atoms, right? It's not a compound, it's not a special element that comes in sets of 2 or 5 or 4 or 8, okay? So all I have to do is take this number and multiply by 6.02. times 10 to the 23. Remember, that's how many particles, atoms or molecules, whichever is appropriate, are in 1 mole. All right, so I take that number and I multiply by Avogadro's number. Okay, and I get 2.81 times 10 to the 22 atoms of copper. Okay, does it throw you when I go from molecules to atoms a little bit? Okay, and that's okay. I mean, that's the purpose of that question, but the purpose of that question is to reinforce what we're finding is particles. If it's a compound, then you're finding molecules. If it's an element, then you're finding atoms. The math is identical. Okay, it's just a matter of were you dealing with an element or were you dealing with a molecule. Okay, any other ones we need to go over? Okay, keep going then. Okay, so on number 9, we have 6 grams of sodium iodide. So we have the mass, okay, 6 grams, and we know it's sodium iodide, so that's going to be NaI. So that'll be 22.99 plus 176.6, oh, 126.9. I always get that wrong, 126. Okay, because they're 1 to 1, right? This is a +1, this is a -1, so that's fine that way. So we'll have our 22.99 plus 126.9. So there's our molar mass. We know we have 6 grams. Okay, so we're just going to go N equals little m over big M. That'll get us the number of moles. Okay, that's our first step. So that'll be our 6 grams divided by whatever was in my calculator there, 149.89. Okay, grams per mole. Grams are going to cancel. It's going to be a pretty small amount here. Okay, so 0.04. Okay, pretty small amount there of molecules, or sorry, of moles. Okay, so 0.04 moles. Okay, now that I know N, I'm looking for the number of molecules. So what do I do next? Multiply by Avogadro's number, right? Okay, if I want to find molecules, I'm always multiplying by Avogadro's number. So it's just this number multiplied by 6.02 times 10 to the 23. Okay, so times in brackets 6.02 E23. All right, and that gets us 2.41 times 10 to the 22 molecules. Okay, everybody all right with that one? Any other ones? Okay, keep going then. Okay, guys, let's quickly have a look at number 10 here. Okay, so we have 1.20 moles of acetylene. Acetylene is the stuff that's in like a cutting torch. Okay, we know the formula for acetylene, so we want to calculate first off the molar mass of acetylene. So that's going to be 12.01 times 2, that's our 2 carbons, plus 1.01 times 2, that's our 2 hydrogen. All right, so that should give us 26.04. Yeah, okay. Okay, grams per mole. All right, so now we've got big M for the acetylene, and they told us, okay, obviously that there are 1.20 moles, so they gave us N. If we're just looking for the mass, okay, we're just going to manipulate the mole equation to get M by itself by multiplying, okay, both sides by big M, and then plugging in our numbers here. So we'll take our 26.04 and multiply it by 1.2. Okay, so we should get 31.25 grams, yep, of acetylene. Okay, any other ones we want to go over, guys? 12? Okay, so 12 is a bit of it's a wording trick, right? Like the story is tricky on number 12. Okay, so it says a student obtained the following data from a reaction between a zinc strip and an unknown liquid. This is the same experiment you did in pair 7 on your reactions lab. You put zinc and hydrochloric acid, okay, and the zinc starts to react and it bubbled and fizzed. Okay, well, if you let that go, you would see that chunk of zinc disappear, because it would essentially be going into solution. Okay, so what he observed was when he started, he had 16.58 grams of zinc. But when the reaction was done, he only had 14.84 grams of zinc. They want to know how many moles reacted. So what do I have to do with these two numbers if I want to know how much reacted? I got to subtract them. Okay, that's the little trick in the question. Okay, is I have to realize that some of it is gone now. Okay, how do I get how much is gone? So 16 was 16.85, right? 58. Good thing I checked. 16.58 minus 14.84. All right, so 1.74 grams reacted. That's going to be my little m for question 12. Okay, that's how much zinc reacted. That's how much grams reacted. I need to know how many moles reacted. So, okay, N equals little m over big M. I take that 1.74, I divide it by the molar mass of zinc, 65.41. Okay, and when I do that, I should get 0.027 moles. Okay, does that make sense? Yeah, it's a wording trick for sure. Okay, any other ones? Okay, how many people are done all the way to 14? Okay, then keep going. Okay, so we have tin 2 fluoride is formed in this reaction. Okay, so this is how we get it. Wonderful. Okay, how many grams of tin 2 fluoride are in 7.42 times 10 to the 24 molecules of tin 2 fluoride? Okay, so we're given the number of molecules. Okay, that's right here. And we're told it's tin 2 fluoride, so SnF2. So we got to calculate the molar mass of that. So 118.71 plus 19 times 2. Okay, because we got 2 fluorines there. All right, so our molar mass, 118.71 plus 38. Yeah, it's 19 times 2. All right, 156.71 grams per mole. All right, so I have big M. I'm trying to find little m, and I have the number of molecules. What do I have to do with the number of molecules if I want to get N? Right, divide by 6.02. Okay, so I'm going to have 7.42 times 10 to the 24 divided by 6.02 times 10 to the 23. That will give me n. Okay, so in brackets 7.42 E24. Whoop, not that. What is that? 24. Close the brackets. Okay, divided by Avogadro's number, 6.02 E23. Okay, so N is 12.33 moles. Okay, I'm going to keep all the decimals in my calculator, but now I have N and I have big M. All right, so N equals little m over big M. I just multiply both sides by big M. So I'm going to take that 12.33 and multiply it by 156. Okay, and that should give me, 1,931, 0.5. Oh, I know what went on there. Okay, old periodic table, different mass for tin. You did it right if you got that number.
Okay, that's what I was thinking.
Yeah, I'll bet. Yeah, that would be confusing to me too. Okay, yeah, totally forgot to update this key for the updated periodic table. Okay, so tomorrow, I think what we'll do tomorrow is we'll do the exam review tomorrow. Okay, we'll still do 4 mole equation questions to start the class, okay, but we'll take a full class to do the unit exam review tomorrow. That way you've got it ready for you under your belt for the weekend. Okay, so we'll do that tomorrow, okay, and then probably a little bit more mole stuff maybe on the Monday. Okay. What?
I really thought it was Thursday, so I had my whole night planned out because I had to study for it.
You thought today was Thursday?
Yeah, I like
Oh,
was
it's gonna
really
be a long
sure it
week
was
for you.
Thursday. I was like, no, I did not.